All right, we're going to start chapter 11, and in chapter 11 we're going to talk all about quadratic equations. Now remember, we've talked about quadratic equations when we did chapter 5 and we did factoring, right? If we have an x squared and an x in our problem, or anytime we have an x squared in our problem, it's called a quadratic. And we can solve what we know if we have an x squared and an x to move everything over to the same side, set it equal to 0, and factor. We've talked about all different types of factoring techniques. Well, in this chapter, we're going to talk about what the graphs of these quadratics look like. If we were to graph it, what would it look like? And then we're going to also talk about how do we solve it if we can't factor? What are some other solving techniques when we have quadratic equations when you can't factor it? Well, when we graph a quadratic, it's always going to look like a U or an upside down U. It's called a parabola. So you can see in the example here that we have the function f of x equals x squared plus 6x plus 8. It's not a y equals mx plus b. It's not a line. It's a parabola. I know that because it has an x squared in my equation. So I know it's going to be a quadratic and it's going to be shaped like a parabola. Now, if you take this parabola and if you plug in 0 for y, or f of x, if you set it equal to 0, and you factor, you actually end up getting x equals -4 and x equals -2. If you notice, -4, 0 is an x-intercept. X equals -4. And -2, 0 is also an x-intercept. So we can actually find the x-intercepts where the graph is going to cross the x-axis of any quadratic by setting it equal to 0, by plugging in 0 for y, like we've done in the past. We're also going to solve quadratics a few different ways. We've already talked about factoring. Now let's talk about what we call the principle of square roots. We've kind of done this opposite in a previous section where we were able to square both sides in order to cancel a square root, right? Well, what happens if we have a square? Well, if we have a square, an x squared in our problem, and there's no other x term, there's just an x squared, then we can solve it by square rooting both sides, because the square root and the square are inverse functions of each other, and they kind of cancel each other out. Now, we have to be a little bit careful, though, when we go to square root. Maybe you remember there's a rule that we have to be careful of. We actually, anytime we square root, when we find the square root of 36, we need to actually add plus or minus to our answer. X equals plus or minus 6. Because think about it. If I were to plug in 6 and square it, 6 squared is 36. But if I were to plug in -6 and square it, -6 squared, -6 times -6, is also 36. So anytime we actually have a quadratic or an x squared, we should always have two answers. So don't forget your plus and your minus anytime you square root. Let's do some more of those. Example number 2 says we have the equation 3x squared equal to 6. We want to find the exact and an approximate answer to 3 decimal places. So what we want to do is we want to solve this. We want to figure out what x equals. What we're going to do is we're going to get rid of all of the numbers, coefficients, numbers that are being added or subtracted to, and then the very last thing we're going to do is square root to get rid of that square. So before we square root, let's always get rid of everything else first. Kind of like when we isolated our radical. We want to isolate that x squared. I noticed that it was an x squared, so I should have two answers, right? Let's go ahead and first get rid of the 3 by dividing both sides by 3. You notice that the 3 was right next to the x squared, which means multiply. So the opposite of multiply is divide. We're going to divide both sides by 3, and we end up getting x squared equals 2. I can now get x all by itself by square rooting both sides. The square and the square root should cancel. Now be careful. Make sure that you add your plus or minus, and you should end up getting x equals plus or minus the square root of 2. Now, it's not an even square root, but what we can do is put it in our calculators, the square root of 2, and say that the square root of 2 is approximately 1.414. So x equals plus or minus the square root of 2, or plus or minus 1.414. Let's do a few more. Example number 3 says we want to solve -5x squared plus 2 equals 0. You notice that we only have an x squared as a variable. It's a quadratic. We're going to have two answers, right? Let's go ahead and solve for x. Let's get all the other numbers away from x. The farthest number away is that positive 2. It's being added right now. So let's go ahead and move it over to the other side by subtracting it. When I subtract 2 to both sides, I end up getting -5x squared equals -2. Now, let's make sure that we get rid of all the coefficients first before we start square rooting. So let's go ahead and divide everything, both sides, by -5. When I do that, I end up getting x squared equals positive 2/5, right? Because two negatives divided give me a positive. Now let's go ahead and get rid of that square by square rooting both sides. The square and the square root cancel, and I'm left with x equals, remember, plus or minus the square root of 2 over the square root of 5 if you wanted to break those square roots up, right? Because, if you notice, we now have a radical in the denominator. And let's go ahead and always rationalize our denominators. So let's finalize this by rationalizing our denominator by multiplying both the top and the bottom by the square root of 5. So I end up getting x equals plus or minus the square root of 10 over 5. Two answers, right? All right, last one, example number 4. What do you think we're going to move first here? It looks like we're going to move the 9. It's farthest away, so let's subtract 9 from both sides. After I subtract 9 from both sides, I ended up getting 4x squared equals negative 9. Let's go ahead and divide both sides by 4. When I divide both sides by 4, I ended up getting x squared equals negative 9/4. Let's get x by itself by square rooting. And I know as soon as I square root, I need to add plus or minus. I know I should have two answers. But I also noticed something in this problem, that there's a negative underneath. We can't have negatives underneath square roots, right? What those end up being, remember, is imaginary numbers from last chapter. So let's go ahead and take that imaginary number and let's simplify it. So I end up getting x equals plus or minus, let's bring that negative out and call it I. I really have the square root of 9 over the square root of 4. They actually both reduce, so I can say that my final simplified answer is x equals plus or minus 3/2 I. Two answers, they happen to be imaginary, but that's okay. I can still solve it and still get two answers. They just happen to be imaginary numbers on this one instead of real numbers. Make sure you get all of your numbers away first before you square root. And then remember, anytime you square root, you have to add that plus or minus.